Okay, I want us to look at the surds, but before we continue, we must know what surds are. So a number that cannot be expressed as an integer or a terminating decimal or recurring decimal is an irrational number. For instance, if we have root 2, root 2 will give us continuing decimals. So they are not determinating. So such a number that will give us a continuing decimal is a surd. So root 2 cannot be expressed as a fraction, neither a terminating nor a recurring decimal. So it is an irrational number. Still, we have other roots like root 3, root 5, and so many others. Those are irrational numbers. However, we also have rational numbers that can be expressed as integers or terminating decimals or recurring decimals. For instance, if we get the root of 4, we know the root of 4 is a 2, which is either positive or negative, and that is what we call an integer, because we know that integers are either positive or negative numbers. So the root of 4 gives us integer. Therefore, it is a rational number. Hope we are together. I want us to first differentiate what a rational number is and an irrational number. We've seen that an irrational number is a number that cannot be expressed as an integer or a terminating decimal or a recurring decimal. And we've seen examples such as root of 2, root 3, root 5, and so on. Then a rational number can be expressed as an integer, terminating decimal, or recurring decimal. For instance, root of 4 gives us a 2, which is an integer, root of 16, and so on. So a surd is what gives us an irrational number. However, we shall observe that the numbers under the root sign are positive rational numbers. Those numbers under the root signs are positive rational numbers. For instance, root of 2. 2 is a positive rational number under the square root. And the roots of these numbers are either integers or can be expressed as a ratio of two integers. Then the numbers under the root are positive numbers, but the roots of these numbers are irrational. And now this is where the point comes from. In part A, we've seen that the numbers are positive rational numbers and their roots are either integers or can be expressed as a ratio of integers. For instance, if I have root 4, its root is 2, so it is an integer. It is either 2 or negative 2. Then, if I have root 4 over 9, 4 over 9 is under the square root, so I will get a ratio of 2. That will be 2 over 3, which is either positive or negative. But if I cannot get the root of that number under the square root, then we call that a surd. For instance, root of 2. We can't get root 2, so it is a surd. Root of 5 is a surd. So therefore, a surd is an irrational root of a rational number. Hope we are together now. We know what a surd is. For instance, root 8. Root 8 is a surd because it is an irrational root of a rational number, whereby the rational number is 8, but its root is irrational, meaning cannot be expressed as an integer or a terminating decimal, neither a recurring decimal. So it is an irrational root of a rational number. Good. Let's continue. So after now knowing what a surd is, we come to simplifying surds. How do we simplify surds? For instance, we have root 72. We know that root 72 is irrational because 72 does not have a square root. But there is a way we can simplify this. Now the logic is we get two factors that you multiply to get 72. But the condition is one of these two factors must be a square number. Now that brings us to something else. What are square numbers? Before you simplify surds, you must know what square numbers are. Reason being, we are going to use them. And you cannot use what you don't know. Square numbers are numbers, or the result you get after multiplying a natural number by itself once. The result you get by multiplying a natural number by itself once. What are natural numbers? Counting numbers starting from 1 are natural numbers, meaning that if we multiply these numbers by themselves, for instance, 1 times 1, you get 1, which is a square number now. 2 times 2 times 2, you get 4, which is a square number. So when you multiply a natural number by itself, you get a square number. Hope we got now what a square number is. Let's come back. We were looking at simplifying root 72, and we've said that the condition is we get the factors of 72, but one of them must be a square number. Probably those factors are 36 and 2, because 36 is a square number. So 72 is the same as 36 times 2. And now, after simplifying 72 to its factors, we shall reduce them, or we shall separate their roots. You get root 2 36 times root 2. But we already know root 36 is 6. So that gives us 6 times root 2, which is 6 root 2. Hope I'm got clear on this. When we are simplifying a root, we get two factors, but one of them must be a square number. We continue. we have to reduce root 8 and root 45. Those will be yours to try out. Thank you.